Hello everyone. In this video we're going to be solving a rational system. We have xyz over x plus y equals 2, xyz over y plus z equals 3, and xyz over z plus x equals 4. And we're going to be solving for xyz values. I'll be presenting two methods, and let's start with the first one. For my first method, if you kind of number the equations like 1, 2, 3, I'm going to divide the first equation by the second one. So I'll divide xyz over x plus y by xyz over y plus z. And that's going to give me 2/3. xyz is going to cancel out, and we're going to flip and multiply these fractions. That's going to give us y plus z over x plus y equals 2/3. And if you go ahead and cross multiply here, you get 3y plus 3z equals 2x plus 2y. The y has a coefficient of 1. Let's go ahead and isolate it on the left hand side. Subtract 2y, you get y, and subtract 3z, you get 2x minus 3z. Now that's the fourth equation. If you want to number all your equations to keep track, this is number 4. We're going to come up with another equation by using the second and the third equation. So we're going to use number 2 and number 3 together. Just divide them. So we have xyz divided by y plus z, and that's going to be divided by xyz over z plus x. And this is going to give us 3/4. Just like with the first two equations, we're going to simplify this. xyz is going to cancel out, and this is going to give us z plus x divided by y plus z equals 3/4. And if you cross multiply, 4z plus 4x equals 3y plus 3z. Now, you might be thinking about isolating z here because z has a coefficient of 1, but looking at equation number 4, it makes more sense if we isolated y. So I'll isolate 3y, so subtract 3z from both sides, and that's going to give me z plus 4x. And we can call this equation number 5. Now, we're going to solve 4 and 5. That is a system. But notice that one of them has y and the other one has 3y. So we have the following system. Let me rewrite these equations. Y equals 2x minus 3z, and 3y equals z plus 4x. Obviously, we can go ahead and use substitution here. Since y is equal to 2x minus 3z, we can go ahead and substitute that. That gives us 3 times 2x minus 3z equals z plus 4x. Let's go ahead and distribute and simplify this. This gives us 6x minus 9z equals z plus 4x. Now, if you go ahead and subtract 4x, you get 2x. If you add 9z, you get 10z. And divide both sides by 2, and you get x equals 5z. We don't really need to call this any equation, like we don't have to number it, but let's just keep it for now. We're going to do something similar. So we found x in terms of z. So let's go ahead and plug it in here to find y in terms of z. So y can be written as 2x, which is 2 times 5z, that is 10z, minus 3z. So y is 7z. That's another equation that we're going to use. So now we have both of these equations, right? We can go ahead and plug them into one of the original equations. So let's take the first one. Looking at number 1, we see xyz over x plus y equals 2. Now go ahead and replace x with 5z, y with 7z, and z with just z itself. And do the same thing at the bottom, 5z plus 7z, and that should equal 2. From here we get the following, 35z cubed over, and then if you go ahead and cross multiply, this is going to give you 12z. Multiply by 2, you're going to get 24z. Now notice that this gives us z equals 0 as a possible solution, because if you go ahead and put everything on the same side, don't cancel out anything. set it equal to 0, you can always take out a z. Therefore, z equals 0 is a candidate, right? I say a candidate because it doesn't work. Why? If z is equal to 0, all of these are going to be 0. So that's impossible. Z does not equal 0. We know that. Therefore, we should only focus on the other factor, which is this one. So our solutions are going to come from there. So if you set 35z squared minus 24 equal to 0, you get 35z squared equals 24. Divide both sides by 35. I know the answers don't come out nicely. That's okay. And from here, we get two solutions for z because there's two numbers whose square equals 24 over 35. And those numbers are square root of 24 over 35 and the opposite of that number, negative square root of 24 over 35. So we got two solutions for z, which means that we're going to have two solutions for x and two solutions for y, because remember, we were able to write x and y in terms of z. So now we know that x equals 5z. So from here, x can be 5 times the square root of 24 over 35, and y, it could be the opposite, negative 5 times this, right? And we also know that y is equal to 7z. It can also be written as 7 times this and the opposite of that. So that kind of gives us all the solutions, but of course positives go with positives, negatives go with negatives. Let's go ahead and take a look at the second method, and hopefully we're going to be able to compare these two methods. My second method is obviously different. Let me rewrite all the equations. So I have x plus y over x, y, z. Now, I want to I don't have that. Never mind. I have x, y, z over x plus y plus z. Okay, so x, y, z over x plus y. This is equal to 2. So I want to flip that and write it as x plus y over x, y, z equals 1/2. Take the second equation. That is equal to 3. And flip it. You're going to get x, y, z equals 1/3. And take the third equation, which is z plus x. That is equal to 4. And if you flip it, you're going to get z plus x, divided by x, y, z equals 1/4. Great. So what does that mean? The reason why we flip this is now it's separable. We can go ahead and separate this, and that's going to give us 3 equations. The first one is going to be, so when you can write it basically like, let me show you one and then the others I'm just going to write. You can kind of split it up into 2 pieces like this, but x cancels out, knowing that x does not equal 0 because it doesn't work. You get 1 over yz plus 1 over xz. So here's what this is going to turn into. Okay, let me go ahead and give it to you now. We get 1 over yz plus 1 over xz equals 1/2 from the first separation. The second one gives us 1 over xz plus 1 over xy equals 1/3. And the third one gives us 1 over xy plus 1 over yz equals 1/4. Now, here's the deal. We're going to add these up, and then from here we're going to get the sum, but everything will be added twice. So I can kind of take out a 2 here, and the sum of these is going to be like 6 plus 4, 10, I think 13 twelfths, right? 13 twelfths. And then if you divide both sides by 2 or multiply by 1/2, I just kind of want to write it in the alphabetical order, sort of. 1 over xy plus 1 over xz plus 1 over yz is going to equal 13 over 24. Now this is nice because we kind of have the two-way sums, and now we have the three-way sum. So I can go ahead and plug one of these in, like each one of these, into this equation, right? And then that way I'm going to be able to get everything. So if you look at the first equation, or in other words, here's what I'm trying to do. Subtract from this, if you subtract from this, this equation right here, 1 over yz plus, what was the first one? 1 over xz. That's kind of equivalent to 13 over 24 minus 1/2. And 1 over yz is going to cancel out. 1 over x is going to cancel out. You're going to end up with 1 over xy. So each equation is going to give you, for example, this one is going to give you 1 over xy. Let's do it here. It's probably easier that way. This one is going to give you 1 over yz, and this one is going to give you 1 over xz. When you subtract each one of these from 13 over 12, and they're going to be, when you subtract, you're going to get 1 over 24, 7 over 24, and 5 over 24. So these three equations, I want to go ahead and I kind of want to cut this piece and carry it here so I don't have to write it again. So like this. Okay. So I want to put this here so that I can quickly use it. So here we got three equations, and we're going to find xyz from here. What are we supposed to do though, right? We're going to multiply these. We can actually go ahead and flip each one of these. Let's do that first. So xy equals 24 from here. Yz is 24 over 7. And xz is going to be 24 fifths. If you multiply these equations together, you're going to get x squared, y squared, z squared equals, this is not going to be a very small number. So, but let me write it like this. 24 squared multiplied by 24 over 35. So this is the critical part. When you take the square root, you're going to get the square root of 24 squared, which is 24, with a plus minus sign. And then the rest is just going to be under the radical. Now this is xyz, but we also know xy, yz, and xz. By substituting each one of these into these, we get the same answers pretty much. Let me go ahead and write those down, and this way you kind of see all the solutions together. X equals plus minus square root of 24 over 35. Y equals plus minus 7 times the square root of 24 over 35. And z is just plus minus the square root of 24 over 35. And remember, we had the ratio x was 5 times z and y times 7 times z, so this also verifies that finding. And this brings us to the end of this video. I thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.